We have talked about forward kinematics, we've talked about rotation matrices and homogeneous transformations. But let's see how we would apply those to a robot like this. This is a 7 degree of freedom robotic manipulator, and here forward kinematics would mean, given all my joint motion, can I figure out what is happening at the end tip? And we have already seen that you can do that by just doing a sequence of matrix multiplications, either using just rotations or homogeneous transformation. But the difficulty in a robot like this is first setting up the coordinate frames, and that's where the DH system comes to the rescue, and it helps you with a recipe for defining your coordinate frames. And just to remind ourselves, remember in the DH system, one of the key assumptions is that your z-axis, and let's say in this case black axis is the z-axis, is aligned along the joint axis. So let's take two consecutive joints, just to see how that might look like. So let's say we take this joint first, and let's assume that we already have a coordinate frame with the z-axis aligned along the axis of rotation of this joint, and the next consecutive joint would be this rotation. So the axis of rotation looks like it has an axis along this direction. So that is your assumption. You already have a coordinate frame here, and you know the next z-axis, and where the origin should be along that z-axis, and how the other two axis should be aligned relative to the z-axis. That you figure out by going through the sequence of 4 transformations that we talked about in DH. You first draw a common normal between the old z and the new z. Then you do translation along z, rotation about z, translation about the new x, and then rotation about the new x to arrive at the new z-axis, and wherever you get the other axis and the origin, that's where your coordinate frame is. Once you know those 4 parameters, then you can set it up as a standard code, and you can just use that for any new situation.